right, so today we're going to be looking at our first actual unit from the A syllabus, which will be the lithosphere. So again, that's just up here. Click the top, click lithosphere number 2. Whenever you see it on the calendar and it says 2.1.1, I mean, that's just how I'm breaking down the different subsections of the unit. So 1 was intro unit, 2 is going to be lithosphere, 3 hydrosphere, and so on. And then the different subsections are 0.1. So 0.1 is going to be the Earth, and then there's different sections within there. So that's what all that means. Second will be natural hazards, then mass movements and soil, then resources. So we're going to start with 2.1.1 today, and that will be the lithosphere. Key question 1, whenever you see KQ1, if you go to the A syllabus, it's broken down into key questions. And so this is key question 1, dealing with the Earth. So structure of the Earth, let's take a look. All right, so most of you have probably seen this back in middle school. It's a diagram of the Earth if you were to just slice it directly in half. It wouldn't exactly look like this, of course, but these colors represent the different layers. You've got the inner core at the very center, all right? You've got the outer core outside the inner core. You've got the lower mantle, and then you've got the upper mantle. And right above the upper mantle is the crust, which is very small. And then above that, you've got the troposphere, stratosphere, mesosphere, thermosphere, and exosphere, which are all the gaseous layers of the atmosphere. We're going to be mostly concerned in this unit about this part with the land. So let's go from the inside out. The inner core, that middle part there, the very, very center of the Earth, is about all the way inside the Earth, about 6,400 kilometers in to 5,200 kilometers in. So it's about 1,200 kilometers thick within the Earth. It is solid, solid iron. Even though it's very hot due to the fact there's so much pressure on it, it is so compact by the pressure pushing on the side of the Earth. There's so much pressure being put on by the other layers, even though it's super hot because of that, it still retains the solid state. The outer core is the next layer, this layer right here. All right, the outer core is 2,900 to 5,800 kilometers within the Earth. So that's almost 3,000 kilometers, so it's thicker. It's semi-solid, so it's almost like it's molten. So it's not quite liquid, but it's not super solid. So it doesn't have the pressure that the inner core has, so it won't be as solid as the inner core, but semi-solid. It's nickel, iron, and other trace elements. The mantle and the upper mantle is between 70 kilometers and 2,900 kilometers. So it's a little under 2,900 kilometers thick. This goes almost up to the edge of the Earth, only 70 kilometers down compared to the rest of it, right? So the mantle and the upper mantle, lower mantle and upper mantle, right? They're going to be solid rocks. They're moving due to temperature differences. But they're moving like super slow. So it wouldn't be like you'd go down and look and you'd see all these rocks like flowing against each other. They move super slowly, but anything with a temperature difference, things are heated unequally in the Earth. The center does not radiate out the heat in all the same direction, nor does the heat hitting the outside of the Earth all come evenly. I mean, the sun sometimes is here. The sun sometimes is here. Sometimes, I mean, every day, the sun is hitting a different part of the Earth. So everything is heated unequally. And it's not just the sun and it's not just the inside of the Earth, but everything is heated unequally. And so you get actual movement of these layers right here, the mantle and the upper mantle. You get like rotational movement within the Earth. And of course, the closer you get to the center, it's hotter than the outside. So these rocks actually will move around in cyclical patterns, which is pretty cool. And that causes what we're going to talk about a little bit later. Then on the upper part is the crust. You think about like the crust of a pie, right? You got the whole pie inside, and then that flaky layer outside. It's very thin, is the crust, right? So it's there's 2 types of crust that are the outside layer. The thinner layer of crust is called the oceanic crust, but it's super dense. And so the reason that it's thinner is because there's water on top of it. So when there's water on top of your crust, it condenses it and pushes it down and makes it more dense. So dense means that you have more mass for the same amount of volume. So it's pushing down and compacting that, so it'll be more dense. And then you have continental crust, which will be less dense, but will be thicker because there's no water pushing down on it. And so oceanic crust will have dense rock like basalt, and continental crust will have less dense rock like granite. And that's it for the structure of the Earth. And we will move on to the next section next time.